Okay, so today we will start talking about Chapter 10, which is on chemical thermodynamics. Now, there are many important thermodynamical processes that are not cyclic in nature. A clear example of such a process that obeys the laws of thermodynamics, but it is not cyclic, is a chemical reaction. In chemical reactions, the final state of the systems are not the same as the initial state. So clearly, they are not cyclic processes. So in this chapter, we will apply the laws of thermodynamics to non-cyclic processes, like chemical reactions and phase transformations of matter. So most processes in nature are not cyclic, which means their final state is not the same as their initial state. And an example of that is a chemical reaction and phase transformations. So one thing to keep in mind while studying these systems is that these systems cannot be thermally and often mechanically isolated from their surroundings, which implies we cannot consider the energies in these systems to be constant. However, we can fix other thermodynamical properties, for example, temperature of the system throughout the process. Similarly, in most of these situations, we cannot keep the volume constant, but we can fix the pressure of the system. So fundamentally, when we are considering these systems, is that these systems cannot be thermally and often mechanically isolated from their surroundings, which implies for most of these situations, energy cannot be considered as constant. However, we can fix things like temperature and pressure of the systems. Now, as a step one, let's consider broadly what is a system and what are the different phases of matter. So section 10.1. So what is a physical phase of a substance? So a physical phase of a substance is usually defined by its molecular structure. So as an example, let's consider water. Chemically, water is H2O. However, it may exist in a number of molecular configurations. And what are they? So ice, liquid, and vapor. So the three phases that water could exist in are solid, liquid, and gas. And those are the three phases that we will be talking about. So the three phases that we will be talking about are solid, liquid, and gas. So if I was to take the example of water, at low temperatures, water takes on a rigid crystalline molecular structure, and we call it ice. So at low temperature, we call it ice. Now, as the temperature of ice is raised, the molecular structure of water becomes a liquid. As temperature is raised, water becomes a liquid. Now, if the temperature is further raised, its molecular structure becomes completely random and it transforms it into a vapor. It becomes a vapor. Now, let's discuss substances. So if we were to define substances, what could the possible states of a substance be? So the two basic states of a substance are pure substances and mixtures. So what is a pure substance? A pure substance is anything that contains the same uniform chemical composition in all of its physical phases. For example, a mixture of water vapor and liquid vapor is a pure substance. On the other hand, air is not really a pure substance because when it is cooled sufficiently, some of its components condense into their liquid state, therefore changing the composition of the remaining gases. Now, pure substances can further be divided into two parts: elements and compounds. Elements contain the same kind of atoms and have well-defined properties, whereas compounds contain atoms or two or more elements, again, with this well-defined properties, but the difference is elements have one type of atoms, whereas compounds may have more than one type. Now, mixtures are categorized into two main things. Mixtures are either homogeneous or they are heterogeneous. Homogeneous mixtures have the same composition throughout. They are either physically uniform, they have a single physical phase, or they are chemically uniform, that is, they have a single chemical throughout. So homogeneous can further be divided into two parts. They are either chemically homogeneous or they have a single phase. On the other hand, heterogeneous mixtures do not have the same composition throughout, and we are able to distinguish the various compounds in the heterogeneous mixtures from each other. So this is fundamentally a very good way of thinking about phases and substances. Now, we're talking about chemical thermodynamics, so we need to now focus in on the different parts of chemical thermodynamics.